Biomedical engineering is a dynamic and interdisciplinary field, combining the principles of engineering with the complexities of biological sciences to create solutions for healthcare. One particularly exciting role within this field for Masters of Science graduates is that of a research and development (R&D) engineer. This position offers a unique blend of hands-on engineering design, scientific research, and discovery, making it an ideal role for those passionate about cutting-edge technology and innovation. R&D engineers in academic settings often work closely with professors who have secured funding for high-impact projects. These projects can involve advanced areas of biomedical engineering, such as 3D bioprinting, where engineers contribute to designing, testing, and refining 3D printing equipment, components, and devices. These engineers do not just design tools, they actively participate in the research process, applying scientific knowledge to experiment setup, data collection, and analysis. They often serve as a bridge between the technical and scientific aspects of a project, helping develop new methodologies and enhancing experimental accuracy. Additionally, R&D engineers play a crucial support role for graduate students conducting experiments, offering mentorship, technical guidance, and troubleshooting expertise. R&D engineers in this role are tasked with designing equipment and components that meet specific research needs. For example, in 3D bioprinting, they might create custom devices that can precisely handle biomaterials or develop testing protocols to ensure equipment reliability and consistency. In addition to engineering tasks, R&D engineers need a strong scientific foundation to actively engage in lab research. This includes hypothesis development, experimental design, and data analysis, which contribute to the team's larger research goals. A significant part of the role involves working with graduate students, guiding them through complex experiments, teaching them how to use equipment, and ensuring they understand the technical requirements of their projects. This mentorship helps to advance the research while fostering a collaborative lab environment. Given the interdisciplinary nature of biomedical engineering research, R&D engineers must communicate complex technical information clearly. They often prepare reports, share findings with their academic team, and even contribute to publishing research in scientific journals. While R&D engineers play a unique role in academic research, the skills they develop are also highly valued in the industry. Biomedical companies frequently hire R&D engineers to work on specific projects that require both technical expertise and scientific insight. Unlike the research-driven focus in academic labs, industry R&D engineers often support clinical trials, develop new product concepts, or work directly with clients to solve specific problems and create innovative solutions. In industry settings, R&D engineers may assist in clinical trials for new medical devices or drugs, ensuring products meet regulatory standards. They develop prototypes and testing methodologies for new products, working alongside design teams to address real-world healthcare needs. They engage in client-facing roles, providing insights on product development to address specific challenges and improve existing solutions. The R&D engineer role is a fantastic fit for young biomedical engineers who are passionate about both engineering and scientific research. It combines creativity and curiosity, enabling engineers to push the boundaries of technology. Whether in an academic lab or industry, R&D engineers make meaningful contributions to healthcare innovation, from discovering new ways to engineer tissues to developing life-saving medical devices. For anyone with a master's in biomedical engineering, this career path offers the opportunity to be at the forefront of healthcare technology and apply skills in a variety of impactful ways. Whether working in academia or industry, R&D engineers are essential to transforming research into real-world applications, ultimately advancing the field of biomedical engineering and improving patient outcomes. Want to dive deeper into biomedical engineering and healthcare technology? Subscribe for more educational content and check the video description for a link to purchase Professor Loai Alzab's ebook, What is Biomedical Engineering for Students and Parents? It's packed with insights, information, and resources to help you explore this exciting field.